All right, so 3.4 is the chain rule, or excuse me, 3.6, oh my. 3.6 is the chain rule. All right, and what the chain rule does is it says, okay, well, let's start with this. What if I told you to, if y equals sine of x, and I told you to find dy dx? What is this the notation for?
Derivative of y with respect to x.
Derivative of y with respect to x. Good. So what is dy dx? Is going to be cosine of x. So what the chain rule does is if I have, well, let me do one more. 2 sine of x. Find dy dx. Dy dx is going to be 2 cosine x. Because 2 is going to be the constant, so those constants are always there. Agreed? It's just 2 times whatever the derivative of this piece is, because this 2 does not have an x with it. If it has an x with it, then I have a chain rule on, or excuse me, a product rule on my hands. Does that make sense? All right, what about this one?
Jesse Grindstaff, Sean Smith, please report to room 279. Jesse Grindstaff and Sean Smith, report to room 279.
So the thing with this one is that the 2 is with the x. Okay, it's embedded in here. You don't have 2 functions. It's not like this. This is 2 functions. That would be a product rule. But if I have the 2 with the x, when I derive this, it's like this piece is not here. So essentially I ignore that piece and say, okay, well, what would the sine of x be? What would the derivative of sine of x be? Cosine x. But it's not cosine x, it's going to be cosine of 2x. So I keep this, I derive this piece, but I keep this piece the same. Does that make sense? And all I have to do is now I have to derive this piece. So I multiply everything by 2.
May I have your attention, please? Teachers, you may begin testing at this time.
Does that make sense? Questions? So what if I told you to find the derivative of 2 sine of 3x? What's this 2 going to do? It's going to stay. Now what I look at is this piece, right? This piece has embedded in it a 3x. I don't care about this right now. I care about this outside piece. What's the derivative of sine? Cosine. So I keep cosine 3x times the whole thing by 3. And when I reduce that, or when I simplify it, it becomes 6 cosine of 3x. Are you with me? Questions? All right, let's look at this one. What if I told you to find the derivative of x squared? Okay, so dy dx is going to be 2x. So what overall function is going on here? Meaning, what does this really look like? Well, this really looks like the one I just did, right? Except now this x is a little bit more complicated. So what am I going to do? I'm going to ignore this piece, right? What would the derivative of this be? If I'm ignoring that piece, it would be 2 in the front And then I would have this black thing, right? And then this 2 would drop to 1. Would you agree? So it goes to 1. I don't have to write the 1. But I have to multiply it to whatever's in that black thing. Now, how am I going to erase that? So, I didn't think that through, did I? All right, so the 2 comes to the front. This goes to 1. I leave the inside the same the first time, and then I come outside and multiply it by its derivative. Are you with me?
So if its derivative on the inside was like, I mean, if it was like 3x squared plus 2, and all of that squared, would you multiply by
6x.
Mm-hmm. Instead of just, okay.
Yeah.
Just making sure that x would come out too.
Yep. All right, so this would reduce to this. And then I could take that 6 through and get this if I wanted to. For many things, I do not suggest this because if it's factored, it's easier to deal with finding zeros and things like that. Okay, let's do another one. So what if I had 4x to the third minus 2x to the second plus 4x plus 49 to the 63rd power? What do I ignore first? Oh, meant to change that. Okay, let's do orange. Ignore this piece for the first part. So I bring 63 in the front. Are you with me?
Yeah.
And I drop this. I drop everything with it exactly as it looks. What does a 63 become? And I multiply by what? The derivative of the inside, which is going to be
12x squared minus 4x plus 4.
Can I write it that way?
No, you need parentheses.
I need parentheses. I cannot leave it with just multiply by that because this is more than one term. Up here, it just so happened to be a number. Here I have 3 separate terms, 1, 2, 3, so it needs parentheses.
Can you leave it aside?
Yeah,
I don't think there's much left to do.
you could full it out 62 times.
I'm good.
Or you could just use like the 62nd row of the Pascal's triangle.
Either or.
With the coefficient.
All right, you with me? All right, let's do another one. Yes, this is acceptable. Very acceptable. I do not want to check your work on this. I can promise you that. All right. You ready? All right, what do I ignore first? The whole inside. So what is the next step going to be? And then sine 4x squared to the second. With me?
Do we do the chain rule?
Times, now what do I ignore? The 4x squared, because now this is another piece, right? So what does that become? Cosine 4x squared.
So do you have to put all of that in parentheses?
I don't have to put this one in parentheses because there's not pluses and minuses anywhere, but it never hurts. If you get in the habit of doing parentheses, you will never screw up where you need them, and it doesn't matter if you don't. Now what do I do?
Do it for it.
4x squared is going to be 8x. The absolute only thing that I would do here is put the 24x in the front. That's the only piece I would clean up. I wouldn't touch the rest. Any questions?
So for the cosine, you would just switch the sign to cosine.
I ignored the orange first, right? And got this. Then I have to go to this inside piece and derive it. So the derivative of sine is cosine.
Okay.
And I don't touch that middle piece, right? So there's a lot of middle things going on here. You with me?
Yeah.
Question? All right, let's do one more. Or let's do another one. All right. Now it's getting fun.
You have a strange definition of fun.
So do we have to do the product?
So we have a product rule,
It's chain rule.
and it's chain rule everywhere. All right, so what do I do?
Do ignore the middle.
Well, first thing, I keep the first. Oh, I was trying to do a little squiggly. That didn't turn out pretty. So there's a squiggly. I keep this one so I don't touch it because there's x's here and there's x's here, right? Therefore, there are two functions here. So I keep the first function. Now I have to derive this piece. Which part am I ignoring first?
31x.
The 31x, because the sine of x, the sine is the outside piece. Does that make sense? All right, so let's do it. What's the derivative of sine? So cosine of 31x
Times 31.
times 31.
Would that all be in one parenthesis?
Do I need it in parentheses?
Like the cosine and the 31?
I don't have to put it in parentheses because there's no pluses or minuses. But again, more parentheses is okay. If you miss a parentheses, not okay, right?
So you still, put the derivative of what's in the parentheses outside of it, even when you're doing the
Yes, yes. Now, I have a minute and 20 seconds, so I'm going to go for the other stuff so you can have this full video. So then I'm going to add to it. I keep this one, and I derive this piece. What's the derivative of this piece? 4. Do I have to have a parenthesis somewhere?
Yeah.
Right here, it must happen because there's a plus sign.
Do we leave it as that?
We leave it as that.
Can we clean it up just a little? Like,
Sure, I would bring the 31 to the front, maybe the 4. That's about it. I might take that 4 through this one, but probably not.
you can leave it